I always try to keep my promises, and 20 minutes ago I said you're going to hear Karl Kuhn from Tektronix talk about adaptive bitrate testing. So everyone find your way back to the seats, and if you're ready, Karl. I know you'll draw them in.
I'm ready. Good afternoon, everyone, and please have a seat. That way you can start your nap nice and early. Okay, adaptive bitrate streaming. Let's share with you what I know about it. One thing I like to do when submitting an abstract to the Bits by the Bay committee is to pick a topic that I really know nothing about, but it gives me a deadline to learn it real fast. Nothing like the pressure of realizing I'm going to be standing in front of this group explaining something that 6 months ago knew nothing about. So you're going to see what I know in the last 2 or 3 months. Why adaptive bitrate streaming? A good question. Consumers expect video everywhere on anything they own. Just think back 5, 10 years ago. Video on everything you own wasn't even a concept. 20 years ago, video on demand to the home was a challenge. Now we expect video on demand right now, sitting right here. You can watch pretty much anything you want. And the level of expectations we have now are very high. We expect it to work the first time and every time. We have no patience for fiddling around, for reading a manual, calling technical support, or calling your 12-year-old neighbor to figure out how it works. We expect to push a play button and something happens. There are no second chances. There is no loyalty to an application or a platform. If it works, great. If it doesn't work, I have no time to waste, and I'll take my eyeballs and my money and go somewhere else. No sitting around waiting for something to load. Even if you're channel surfing at home, if you're looking at a blue screen or a black screen for more than 2 or 3 seconds, you're surfing right along to the next channel. It's the same way with an app. You hit the play button. If it doesn't happen 5, 6, 7 seconds, depends on how compelled you are to stick around, you'll find something else to do with your time. Buffer waits. We don't want to sit around, playing a file, then all of a sudden it goes into buffer mode, and gee, I hope it comes back, and let's see if it ever does. Oh, there it is, and it continues playing. We have no tolerance. We become very impatient very quickly. We expect everything to work the first time. And I'll turn that off. Have my clock here. Okay, blockiness or freeze frame, not tolerated. Today's world, we expect it to look good. Look good all the time. Blockiness and freeze frames. Freeze frames, there's no tolerance from that. My mother would complain about the freeze frames on her TV. But it's all about quality of experience. Really what it is, the experience of consuming the content. Because really this business is all about the content, and the quality of that experience is what matters. Pull is more efficient than push. I'm getting to the punchline here because, like most of us, my job, I have to stay current, and it seems like there's always something popping up that, well, maybe I'll pay attention to that. Maybe I won't. Maybe it'll go away. Don't have to worry about it. But I said, no, adaptive bitrate streaming, I don't know about it. I'm not ready to jump on the bandwagon. Pull is more efficient than push. It's all about the last mile. What does that mean? I was visiting a large cable company, one of my customers, and a young man was explaining he was brought in to get involved with adaptive bitrate streaming. And I said, bluntly, why should I care about ABR? He goes, okay, you have cable at your home right now. Yeah, I do. How many channels is the cable company pushing to your house? 200 or 300 maybe? I really don't know how many channels are coming to my house. The point he made was, how many am I watching right now? I said 0. But they're sending hundreds of channels to your house right now, and you're not watching any. Yes, that's a problem. We're wasting bandwidth. We need to change it to from a push to a pull technology. Meaning, if I want to watch it, I pull the content to me. Don't send me content I don't care about. Only send what I want right now. The challenge is the last mile. If I'm looking at an app, I'm watching video of whatever in my home, and it starts doing something crazy, I don't blame the connection in my house. I blame the connection of the network I'm paying for. And that's a problem, because the perception of quality of experience doesn't really know where to point the finger of guilt, but I'm paying for a service I want to enjoy, and if it doesn't work, I don't say the problem is right here, right now in my house. If my son's visiting, he's downloading who knows what, all of a sudden the bandwidth in the house gets constrained and my quality of experience goes down. I don't blame my son typically, but I should. But what it's all about, the client-side player determines the availability, the bit rate that's available right now. That's the beauty of it. Because in a pull technology, the last mile, the last 100 feet, the last 20 feet is the challenge. But the client-side player knows how much bandwidth is available right here, right now, and it adjusts accordingly. It adapts to the available bandwidth of the client. And that's a beautiful thing. It's all about continuous delivery of the content, smoothly with a high quality of experience. Regardless of whose problem it is in the network, let's try not to make it something I point the finger of guilt to the network supplier. But once again, it's all about quality of experience. But we do accept, what the human being is very good at accepting is low resolution and a blurry picture. If there's an artifact that we accept, it's blurriness. If I take my glasses off right now, you're blurry. That's life. You take off your glasses, I'm blurry. If we take off our glasses and the room looks blocky, don't move. I'm going to call 911 and we'll get taken care of, because blockiness is not something that exists in our everyday life. Blurriness, I accept. So if you have to pick an artifact, an impairment, go with blurry. High-level testing concepts. We're all technical people. You get right down to it in one way or another. Our entire careers, we've been worrying about testing, being concerned with quality of service. The error rates, the bandwidth, transmission latency, jitter, instabilities, drift. But the world is moving away from that. It's still a concern, but where the real focus is in the business world, and as I always say to young students that I speak to be successful in this industry, you have to understand the creative, that's obvious, the business, because there's always money moving around somewhere, changing hands, but there's technology behind it. If you understand all three, great. Quality of experience is the money. That's what management, the CFO, and all these people are concerned about. Quality of experience, the end user will notice and the phone will ring. That's a problem. If they even bother to pick up the phone and have it ring, you might be lucky. Management will notice. That's the focus. Why do they care? Because it's dollars, it's revenue, it's a business. What people don't tolerate: access times, buffer wait times, black frames, freeze frames, blockiness, on and on. Closed captioning, that's a big one. If I expect closed captioning, it needs to be there. Management will notice. What do I mean by that? I work with large companies, and the morning status meeting, the top executive says, what are my top 10 quality of experience issues I have from yesterday? At the staff meeting, executive stands up saying, okay, staff, these are the top 10. Make them go away, because this is costing us money. We have churn. We have customer satisfaction issues. We have 20-minute queues on customer service call line. We're losing market share. Make these problems go away. Okay, quality of experience, then what do? Look at the quality of service to figure out why people are having quality of experience problems. But it all starts in executive land with quality of experience. That gets their attention. In my training that I do, my seminars, I stress to technical people, this is the way we think. We've got to learn to think this way, because this is what management cares about. When you go in and start talking about, well, we have bandwidth issues, error rates, all executive management hears is blah, 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 blah. And they hope you go away. If you walk in and can talk business reasons, oh, we're having truck roll increases, we're losing market share, we have our competition is growing and we're not. That gets their attention. Communicate in business terms. You talk about quality of service to an executive, they hear nothing. You talk about business, you have their attention. So what we're doing, we're moving to an HTTP-based delivery. What's nice about that, it's everything you own can handle that. Firewall restrictions aren't the big deal. No special proxies or caches, it's just basic internet traffic. So ABR looks just like another file on a web cache server. It's as simple and as generic as anything gets in a network. Simple web activity. Because what you're looking at with ABR, as far as the network is concerned, maybe oversimplified, you're looking at a web page that has moving pictures and sound. Everything you own can look at a web page. Two different technologies. Segmented, non-segmented, fragmented, and segmented and fragmented. The purpose of my conversation here today is talking about the fragmented, segmented world of ABR, adaptive bitrate streaming. Look at it this way. Every 2 to 10 seconds, you're sending a standalone file. Standalone. Which means you can jump higher and lower in bit rates. So where are we going with this? Apple, most popular. I mean, they have more revenue than oil companies, so why not? Microsoft, smooth streaming. Adobe, they're popular. But there's a problem with this. Every content supplier, which really this business is about the content, has to be dealing with 3 different flavors of every piece of content they crank out to the world. Not a good business case. So the world is moving to Dash, a new unified standard. But right now, that means they have to deal with 4 different delivery formats. But eventually, the migration will be to Dash. Dynamic adaptive streaming over HTTP. Replacing existing proprietary technologies, and this can't happen fast enough. If you're in the content creation business, get me there as fast as you can. If you're in distribution business, Dash sounds like a really good idea. Get everybody on the same page, simplify your QC problems, your workflow. There's less to go wrong. Unified standard, talked about that. Other advantages, trick modes, fast forward, rewind, all the stuff that we expect when we're watching content in today's world. And you think there's a business case with dynamic advertising insertion. There's a business case. iChart, I don't expect you to see this, but I believe the slides will be available for your reference. But what it gets down to is the matrix showing the difference between all the different flavors I just talked about, how they're the same and how they're different. ABR profiles, which is really what we're getting down to. Transcoding. Remember when transcoding used to be a big deal? Now transcoding is business as usual. How many different flavors do you want? I'm working with some people that are cranking out 70 to 80 different types of files for global distribution. It's not getting simpler. It's getting more difficult. There's something nice about holding a digi-betacam tape in your hand, saying, this is my content. I'll put it on a shelf, I know where it is, and you know where you can find it. Now I have 80 different files moving around the planet. I sure hope they play when the customer gets to it. So it's about transcoding to the proper required output. It's all about, we're trying to get quality of experience to be high, so we need different profiles. As you can see here in the graphic, starting at 3 megabits, going down to 150 kilobits. So it depends on what bandwidth is available right here, right now, is which file you're looking at. If the bandwidth constraints get tighter, you go to a lower bit rate. If the network opens up, like my son stops downloading something, then I can go to 3 megabits per second, and gee, the picture looks good all of a sudden. So how many different outputs do you need? 4 to 16, but I think this is what I'm typically seeing right here with customers I'm working with. So it's all about scaling for each client device. Small screen, bigger screens, it all makes sense. The beauty of the network is it's pretty basic. As I said, you're looking at web pages with moving video and sound. The rocket science is right in here. Transcoding. I transcode to different profiles. What bit rate from kilobits to megabits. The network constraints decide which one you're looking at a given time. Interesting part about they're fragmented on 2 to 10-second boundaries. So they're standalone files that might be 2 to 10 seconds long. So as the bandwidth availability changes in the network, I go up, I go down on 2-second increments. So it's very nice as far as something changes in the network right now, I adapt to it right now. So it's simplicity of the network on the delivery side. You're looking at web pages. It goes out here. Let's call this the last mile, the last 20 feet in my house. As bandwidth changes here, it goes back up here and says, give me more or give me less right here, right now, seamlessly, which is the beauty of what we're talking about. No load times, no freeze frames. If anything happens, you overcompress, and it looks a little blurry, you don't have the resolution. So an easy way to get compression to a low bit rate is to filter it, get rid of the high frequency content. Pre-filtering, get rid of the noise if there is any, but soften up the picture. It's a lot easier to compress. Encoder Boundary point, this is from the Cable Labs website that I went to. What it's all about, your transcoder has to tell the network where is a good place to fragment. So the encoder boundary point is where the transcoder says, this is an iframe, and this is the beginning of a new, let's go back, the beginning of a new file, which means it's not dependent on what came before that. If you're jumping up and down in bit rate, you can't be having any reference frames to a previous independent file. They must be separate. So the encoder boundary point tells the system, this is a good point to put in an instantaneous decoder refresh, an IDR. The EBP is a flag to tell downstream, the system downstream, this is where you should look to find instantaneous decoder refresh. And what that IDR means, from here on in, this iframe has no reference to what came before that. So it's a nice, clean boundary point to start a new fragment. So it's all about efficiency. The EBP just says, system, don't be looking at every IB or P or even every iframe for an IDR. I'll let you know when there might be one in there. Then you drill down deeper, which takes time. It takes processing power like everything else does. It doesn't happen for free. And then the efficiency is improved by if there's no EBP, it doesn't bother drilling down to see if that's the beginning of a new file. And now we've put our EBPs in. Now we go to the fragmenter, and we start chopping up the file. Starts on an iframe, because that's how you start a new file, is on an iframe. And then it goes from there. And the beauty of it is it needs to jump from higher to lower bit rate as needed cleanly. That's the whole idea. If it's not a clean jump from higher to lower, your quality of experience goes down. This is all about quality of experience. All right, let's walk through the process, kind of starting at a high level. And okay, here I am. Hello, I would like to watch a movie. And your client goes out. Authentication. Is this device allowed on this network? Is this end user in good standing as far as billing, and are they asking for the proper level of service that they're entitled to? And if that works, okay, let's watch a movie. I want to watch Superman 3. So when it goes out to the network, how much bandwidth is available for this session, and it says, where is the asset? It has to find it. I make the request to consume it. It has to go out and find it. Do I have the asset in the edge? If it's yes, okay, we start consuming it. If it's no, it has to go out to the network. The whole idea is to have your edge cache with only things people are looking at right now. Don't clog it up with things that should be deeper in the network or even archived. If it's in archive, it takes a little bit longer to get, but hopefully the people are motivated long enough to stick around to see it. Okay, so I go through here, the manifest file. What's a manifest file? I look at it this way. It's like the table of content that is inserted into the stream so the receiver knows what's available. The receiver doesn't know anything as far as what bit rate is available, how it can go up and down as needed. So the manifest file is a table of contents that tells the receiver what's going on. A table is a fill-in-the-blank form, because we all fill in the blank forms every day online on hard copy, but this is one that the system creates so a receiver can look at it and say, oh, okay, here's what's available. Because the problem there is, if it's in the manifest file, it actually needs to be in the stream. From my limited experience, that seems to be a common problem. It goes to find a file bit rate, that's not there. Or you have file bit rates available, but they're not in the manifest. So they must map correctly between what the transcoder is doing, the fragmenter is doing, to what's actually in the stream. It must be accurate, and it must be accurate right now. So if everything goes well, you consume the content, and you come back and spend more money. Active and passive monitoring, two different approaches. The one that everybody seems to be excited about right now, from my experience, is active monitoring, where you're doing network loading and simulation. You are a client. You make a request, and hopefully things go smoothly. If not, well, then the error flags go up. Maximum load, you can either do a one-to-one or round robin. Many one-to-ones or many round robins. So it depends on how deep you want to go and how much traffic you have and how much hardware you want to throw at it. As networks mature, then people say, I want to do many one-to-one constantly, because the challenge with ABR, there's not a whole lot of people making money today. A lot of business cases are saying this is the future, here's what we have to need, and if we're not a player, someone else will move in. But there's not a lot of money being made right now with this technology. So everybody's kind of saying, well, how little can I do right now, and then ramp up as the business case can justify? Because all this is about content, but it's all about the business. The manifest syntax, that fill-in-the-blank form, that is the table of contents, it's got to be properly structured. The content's got to be accurate, and the structure of the file itself must be valid. If it's not valid, it doesn't map to the playlist and the current bit rates available, you have a quality of experience problem. So manifest alerts, that seems to be a big one right now, making sure that everything is mapping correctly and things are happening smoothly. If it's changed, if there's a fetch failure, you need to know about that. It needs to be flagged. Also in active, you're actually doing decryption, because there's very heavy-duty encryption in this technology. The key is pages long, single-spaced. It's pretty deep, because the whole idea is this is high-value content that is out in the wild. It's on the internet, so you want to make sure anyone intercepting it has a hard time decrypting. It's not impossible. Nothing's impossible, but is it worth the effort? So you have to be able to decode it to make sure it's actually good content. You have to validate the fact that it's the correct asset, a visual validation of the assets. Is it looking at a black screen, color bars? Is it moving video? Does it have sound? You start getting deeper into the quality of experience as far as blockiness, freeze frames, loudness issues, closed caption availability. You start getting very deep. That's where you need to go, but it's really all about a real-time status information, because I'm decrypting, I'm loading, and I'm simulating. Because the whole idea here, these are expanding networks, and as you know, all networks get more congested with more users, and video is a bandwidth hog to begin with, so you need to make sure things are happening right now. Passive. There's slow movement into this. This is actually looking at, you're not loading it, you're surveying the kingdom to see if everything is going well, if everything is a green light, if everybody's behaving themselves out there, kind of a high-level view of what's happening with the big picture. So what you're trying to do is provide specific information per viewer. You have thousands of viewers. What trends are you seeing? What demand is out there? Because that's how business cases are developed. You know, what's hot and what's not. And this is kind of off topic, but I was visiting a large cable company, and they kind of know what people are watching. And they actually told me, not specifically, that in their network, there was 4 networks that no one tuned to in several weeks. They might channel surf through it, but tuning to it means I want to watch that channel, not just accidentally bump into it. I would consider that sensitive information. If I was an advertiser, I think I'd want to know that, but that's our secret. Okay, so we're trying to find out here what's happening in my network, real time, profile switches, okay. How much adaptive bit rate is actually being done? How do you need to adjust your fragment size because you need to make sure this is happening smoothly? And right now the industry is young enough that we're trying to figure out what is the secret formula? What's the best configuration? Because you're trying to make this as efficient as possible. And if you're finding out that people are quite happy and they're not using the higher bit rates, well, that frees up a whole lot of network by not having to worry about producing content that no one's watching. So what we can do, you must have traffic. One of the weaknesses of it is if there's no traffic, there's nothing to monitor. So you can't monitor unviewed assets. This is passive. You're sitting back saying, what's happening in my kingdom? And if no one's watching a network, well, you don't know if the system is working or really if no one cares. So it's good to know you can't ask questions. You're just sitting there seeing what's happening. That's where the active comes in. It actually fires off sessions, stresses the network to see if it's actually working when somebody wants to watch it. Status codes, well, 400 and 500 codes. You played around the internet long enough, you've seen that, and it's never good news. Where informational, well, it's nice to know. Success, well, we'll give that a green code, because green is usually considered very good news. 300, redirection, well, okay, redirection, does it actually go somewhere when it's redirecting? Well, if not, you might have a client error or a server error. This is what management wants to know about, because someone's disappointed. And quite often it's a CFO that's disappointed. Overcompression, high quality picture, even though we consider blurriness and overcompressed, not blocky, because blocky slice errors, typically that's a transmission hit. There's missing data, and the decoder's trying to fill in the missing data with whatever. It might be green, magenta, checkerboard, or macro blocks from a second or two ago. But anyway, overcompression, if you're going to do anything, make the picture soft, people accept it, and if it gets better, everybody's on board. Fragment load times. This is where you're actually going in to see what's happening in your network. This is active. What we're trying to do is stress your network, and you're looking for outliers. If everybody's behaving, you have kind of flat lines, and you can click on these and change the legend for the codes. You're trying to find out, do you have a nice bell curve distribution? And all your testing, you're trying to have a nice tight bell curve. It starts to flatten out, you start having tails. You start getting out in the tails of the 10%, that's where you're really having a problem. Because you're trying to have everything consistent and smooth, and everything in the world of IP that we're dealing with, the challenge is smoothness, because packets can be lost, duplicated, or out of sequence, and that throws all this out the window. Okay, so now we're going to look at fragment load times, fragment load latency. And if I have a lot of this going on, why am I having these hits? Is that something that's creating a quality of experience issue? Is it a quality of service issue? But once again, flat lines, everybody's behaving where your min, max, and average are fairly close together. If not, then you have a network that may not be all that stable. And that's what you're looking for. Fragment load latency. So what you're trying to have here, there needs to be some pre-buffering. If you're going up and down in bit rates between different standalone files, they need to be in the device before they're actually needed. So there needs to be some pre-buffering. So if you have fragment load latency issues, you might have a quality of experience hit, because the file needs to be here before I need it, not when I need it, and definitely not after it's needed. So you want nice flat distribution of your graphs. Port statistics, kind of hit on this before. Bit rate, that's always a favorite one regardless of what we're talking about. What kind of bit rate are we having? What do we expect? But the manifest bit rate, it needs to be within a bound of a min-max that makes sense. If it drops too close to 0, it's probably not a good manifest file. If it's incredibly high bit rate for a manifest, it's a table. It shouldn't be that complicated. Maybe there's corruption or something going on that's creating an instability in the manifest itself. Non-manifest bit rate, which is all about the content, and that's what we're trying to get through the pipe anyway. Error counts, looking at errored seconds or total counts. Like total count is a total count up, but a errored second is 1 second of time that perhaps has one error or hundreds of errors. Because 1 second is a time that a human being can comprehend. So how many errored seconds gives you a figure of merit, the stability of this network or most other networks. Fragment size, load time, bit rate, latency, we kind of talked on that earlier. But those are all important aspects of active testing because you want to see how stable your network is, what it takes to crash it, and make sure that, because the business model is always, everybody wants to make sure the content makes it on a cold Friday night when there's content that is just introduced. That is the golden opportunity to make revenue. If you can't produce content on that night, revenue will not be made up the second or the third night, because most people want to see it the first chance it's available. If the system crashes, the CFO gets involved. So that's what I know about ABR. Questions, I might know an answer. I'll be here the rest of the week. Thank you very much.